Hello everyone, welcome to the ASM classes. Today we are going to discuss about the concept of pipelining, which is used for increasing the speed of the processor. So what is a pipeline? Pipelining is used by virtually all modern processors to enhance the performance by overlapping the different stages which are involved for the execution of an instruction. So the speed of processor can be increased in two another ways also, by increasing the bus of the data size and by increasing the frequency. Now currently we are working on a 64-bit processor. Now 64-bit means we can execute a operation on 64-bit of data. That means a 64 data is executed at a one time. So for 64-bit, 64 wires are needed. That means 64-bit data bus is used there. Similarly, if we talk about the frequencies, today's processors are working on a gigahertz frequency. So now if we want to increase the speed of the processor, first is that we can increase the size of the data bus from 64 to 128-bit, and we can increase the frequency from gigahertz to terahertz. So up to how much limit we can increase the size of the data bus, and by how much we can increase the speed of the processor by increasing the frequency. So beyond these two concepts, there is a one concept which is called pipeline, which is used for overlapping of the stages, because the different stages are independent of each other and at the same time they can be executed. So here we are going to take a common analogy for understanding this pipeline concept, which is for a particular problem in a factory on an assembly line. So we are assuming here that there are three stages: welding, painting and polishing. So for simplicity, we are assuming that each stage, that is welding, is to be completed in 1 hour, painting is also going to be completed in 1 hour, and polishing is also to be completed in 1 hour. So if in a factory there is only one person for all these operations, and if we have 4 boxes, then the first box will take 3 hours, as 1 hour is for the welding, second hour is for the painting, and third hour is for the polishing. So first box is completed in 3 hours by a one person. Similarly, if there are 3 boxes, then these 3 boxes are going to be completed in total 12 hours. But what the concept of pipelining says that these 3 stages, that is welding, painting and polishing, are independent of each other. Now if in a factory there are 3 persons doing different jobs, this person will perform only the welding work, this person will perform only the painting work, and this person will perform only the polishing work. So when the first box will enter in an assembly line, the first job is to weld this particular box, which is going to take 1 hour. In the second hour, this box from the welding shop will be transported to the painting shop. So in that particular hour, the painting of this box will be completed. But when the painting of this box, that is of first box, is going on, this welder is not doing any job. So at that time, when the second hour is going on, second box will enter into the assembly line for the welding. So at this point, this second box is entered for the welding when the painting of the first box is going on. When this painting of this whole process will be completed and the welding of this box is completed, that is of the second box and this is first box, because every stage is taking 1 hour, this box will be shifted to the polishing shop there. So the first box is now transferred to the polishing. At the same time, welding is also over. So the second box will be transferred to the painting shop, and in the assembly line, third box will come for bending. So there are now three boxes on the assembly line. So when this third hour will be completed, this first box will be out of the particular assembly line. So first box is completed. Now for the second box, only the polishing operation is remaining. So in the fourth hour, this second box which is painted will be shifted to the polishing, and it will be completed in 4 hours. Similarly, this third box will be shifted to the painting shop, and from the painting shop to the polishing box. That means in the fifth hour, third box will also be completed. And when the polishing of the third box was going on, the fourth box is coming for the painting, which means in the 6 hours we will complete all the particular 4 boxes. Now this can be understood in this way. We have this time axis. This is 1 hour. So here is the first box for the welding. This is 1W. Okay. In the second hour, this first box is gone for the painting. So when the painting of this first box is going on, second box will be entered into the assembly line for the welding purpose. Now when this painting is over, in the third hour, the box, that is first box, will enter for the polishing. So when the polishing of the first box is going on, this box, that is second box, its welding work is done and it will be shifted to the painting process. So when this painting of this process of second box is going on, the welder can do the welding of third box. So in this way, what we are seeing that in the assembly line there are 3 boxes. The first box is in the final stage, second box is on the painting shop, and third box is on the welding. So after complete 3 hours, first box will be ready. Now what is the job remaining for the second box? For the second box, only the polishing work is remaining there. So in the next hour, that is after 3 hours, in the fourth hour, second box will be polished and second box will be ready. So when this second box is gone for the polishing, the third box came for the painting, and in the assembly line, fourth box enter for the welding there. So in the fifth hour, as we are seeing that the job of the third box to be painted is completed and it will be shifted to the polishing. So when this fifth hour will be completed, third box will be completed, and at the same time painting of the fourth box will begin when the polishing of third box was going on. So in the 6 hours, this fourth box will be completed. This is called pipelining, that when there was only one person, total hours taken by it is 12 hours. When the 3 persons doing 3 different jobs, the 4 boxes were completed in total 6 hours. So this is the way in which we are going to increase the speed of the processor by overlapping the several different stages. Now we will understand this concept of pipelining in the processor. So if one or more process, that is stages, are independent of each other, they can be executed by processor at the same time. Now taking an example of two-stage pipelining, that is, we have an instruction. So this instruction is in memory. This instruction has to be fetched, and after fetching it into the processor, this particular instruction will be executed. So if we consider that we have total 5 instructions, okay, we have a 5 lines program, 1 2 3 4 and 5. We have a 5-line programs, okay. So in a normal processor, the first instruction is first of all fetched and then it is executed. So after all these operations, the first instruction is over, then processor will execute second instruction, and for the second instruction, fetch operation will begin, execution of the second operation will begin. When this whole process of this second instruction is over, third instruction will be fetched and third instruction will be executed. In the similar way, fourth instruction will be fetched and it will be executed. After its completion, fifth instruction will be fetched and it will be executed. So if we suppose that each stage is taking one cycle, then total cycle is 1 2 3 4 5 6 7 8 9 and 10. That means 5 into 2, that is equals to 10 cycle taken by the normal processor. But if we see this concept in the pipeline processor, so in the pipeline processor, what is happening? As fetching of the instruction is done from the memory by the processor, so fetching is from the memory and execution is inside the processor. So both these operations, that is fetching and execution, are independent of each other. Why? Because when this instruction will be fetched, then only execution can take place. So now let us see this concept in the pipeline processor. We have a 5 instruction, that is 5 lines program, 1 2 3 4 and 5. So this is first instruction. So the fetching of first instruction is started. After fetching, execution of the first instruction will be begin. So when the execution of first instruction is going on inside the processor can fetch the second instruction from the memory because they are two independent processes. So when this execution of the first instruction is going on, at the same time fetching operation of the second instruction is started, and after that execution of this second instruction will begin. So in this cycle, whole first instruction is over. In the second cycle, when this execution of second instruction is going on, fetching of third instruction will begin, and when the execution of this third instruction is going on, fetching of fourth instruction will begin. And after that, when the execution of this fourth instruction is going on, fetching of fifth instruction will begin and execution of the fifth instruction will be completed in this cycle. After that, there is no more instruction. So whole of the instructions take 1 2 3 4 5 and 6. That is, in a 6 cycle, the whole 5-line program is completed by the pipeline processor, whereas the normal processor has taken a 10 cycle for execution of the same 5-line programs. So in this way, we have saved 4 cycles. So by this means, we are increasing the speed of the processor by saving the number of cycles there. So this is the example of two-stage pipelining. Now we are going to look on the three-stage pipeline processor. So in the three-stage pipelining, we have three stages: fetch, decode and execute. Okay. So if we are again considering that we have a 5 instructions, that is a 5 lines program, 1, 2, 3, 4 and 5. This is first instruction, second instruction, third instruction, fourth instruction and fifth instruction. All the instructions are stored in a memory there. Okay. Now this is the processor. Processor has to execute each and every instruction. So first of all, processor will fetch first instruction. Now what the normal processor will do? Normal processor will fetch first instruction, then it will decode it, then it will execute it. After all these three operations, the second instructions operation will begin, that is fetching of second instruction, decoding of second instruction, execution of second instruction. In the similar way, when this I1 and I2 are over, I3, that is third instruction, will be fetched, third instruction will be decoded and its execution will be completed. After the completion of all these three cycles for the third instruction, fetching of fourth instruction will begin, decoding and then execution of the fourth instruction, and after that fetching of fifth instruction, decoding of fifth instruction and execution of fifth instruction. So total time taken by the normal processor for three-stage pipelining is 5 into 3, that is equals to 15 cycles. But now we will see all this concept in a pipeline processor. So when the pipeline processor is working, then there will be an overlapping of stages, that is fetch, decode and execute. Now let us look at the pipeline processor. The first instruction will be fetched, and in the second cycle the decoding of the first instruction is going on. So when the decoding of this first instruction is going on, decoding is going to take place inside the processor and fetching operation is done from the memory. So these two processes are independent, that is fetching and decoding. So while the decoding of this first instruction is going on, the fetch operation of the second instruction begins. Now after the decoding of the first instruction, the stage remaining for the first instruction is execution. So in the third cycle, execution of the first instruction is taking place. Now execution is again done in a processor, and this decoding and execution are two independent processes inside the processor. So what we are saying, fetching, decoding and execution, they are three independent processes. So while the execution of this first instruction is going place, second instruction's decoding process start, and when the execution of first instruction, decoding of second instruction is going on, in the same cycle, fetch operation for the third cycle begins. Okay, so in this process, fetch for the third operation is going on, decoding of second instruction is going on, and execution of the first instruction is going on, because all these three stages are independent of each other. This is the concept of pipelining. Now this whole instruction takes 3 cycles, that is first instruction will take complete cycle, that is 3 cycles. But what you will see in the fourth cycle, this is first cycle, second cycle, third cycle. In the fourth cycle, execution of second instruction will begin and decoding of third instruction will begin. At the same time, fourth instruction will be fetched. Now in the fifth cycle, execution of third instruction will be completed, decoding of the fourth instruction will be completed, and fifth instruction will be fetched. Now what is remaining? Remaining is the execution of the fourth instruction and when the execution of fourth instruction is going on, decoding of fourth instruction starts. Now, as we have only 5 instructions, so the last operation is the execution of the fifth instruction. So what you will see that in total 7 cycles, the whole operation is completed, which means that total 7 cycle as comparison to the normal process, because normal processor has taken 5 into 3, that is 15 cycles. So that means we have saved 8 cycles there. So as we are going to increase the number of stages, this number of cycles will be large and the speed of the processor increase in this way. This is called the concept of pipeline. Now the last thing is that if we have n number of stages, n is equals to number of stages and k is number of instruction, then a normal processor is going to take k into n cycle. Okay, normal processor is going to take k into n cycle, where n is the number of stages and k is the number of instruction, whereas pipeline processor will take n number for the first instruction. Okay, so n is the number of stages, n cycles, and after that how many instructions are left? After this third cycle only 4 instructions are left, because first instruction has been completed in this whole cycle there. Now the remaining are 4 instructions. So 4 instructions will take 1, 2, 3 and 4. That means k minus 1 time. So total cycles are n plus k minus 1. So n is the number of stages. So if we look for this particular example, n is equals to 3, k is 5, so total 3 plus 5 minus 1, that is equals to 7 cycle there, whereas normal processor is going to take 15 cycles there. This is the concept of pipelining. If you liked this video, please press the like button. Thank you.